Hello everyone, and let me start by focusing on the purpose of today's lecture. Probably all of you are biologists, maybe some of you not, but most of you. And the purpose of this lecture is to give you the mathematical background for you to be able and solve and understand things in the course. As you see, it's a mixed course with mixing biology and mathematics together. Let me say something before about why do we need the mathematical models. Can anybody know? Anybody give me some idea? Why is it good for? Why not just doing experiments like we did? Anybody?
To predict.
Exactly. When you have a mathematical function, right? Like if I know the amount of a protein by the model, right, as a function of time, I can predict how many of protein I will have. I can know what will happen to the system after a long time, etc. So that way you save time, you save money, right? You don't have to do 2,000 experiments if you know approximately what will happen to the protein, etc. Feel free to ask questions, and the purpose of today is for you to understand the mathematical model. Okay, so I will not, of course, I cannot do everything that we will do in the course. We will focus on something that's very important that is like the base, the fundamental function that we'll go over in the next few weeks in the course, okay? And this you've seen in the lecture, dy over dt equals beta minus alpha t. Okay, so the first thing I will have to say about it, okay, maybe let me start by emphasizing what is each one of them, okay? dy over dt, okay? It's the derivative of y in time. What is the derivative meaning? Is the change of y, okay? Out y, the amount of protein, the amount of RNA, depends what we will say y is. How does it change over time, okay? What is the dynamic of the system? So we ask, how is the change, okay? Y change, okay, change of y, okay? How does it, the change over time? It change, sorry, it's not t, it's y, okay, sorry. It changes by a constant beta, which is the synthesis constant, okay? Which means how fast do we build the protein, okay? And alpha y is the degradation and dilution, okay? Alpha equals alpha dilution plus alpha degradation, okay? Okay, I will write bigger. Alpha degradation plus alpha dilution. Okay, yes?
So you say Y is protein?
It's not, it doesn't have to be protein, but maybe it will be mRNA sometimes, etc.
So how big is T?
Okay, T, okay, I didn't say anything about T. T is time, right? T is the time that we look at, okay? The purpose of it is to find a function y of t, meaning y, I don't know, for example, equals 2 square beta, whatever, okay? Meaning if I want, the purpose of it is to find a function that if I plug the time, I would know the amount, okay? So t can be anything between 0 to infinity, okay? So the first thing I want to say about this equation is that it's what? It's not a regular equation, right? A differential equation, which is what does it mean? It means that there is a derivative in the equation. But first, we need to know that it is an equation. So what is an equation? Can anybody tell me what is an equation? Okay, it's a rule that we're looking for a solution. Okay, what does it mean? Anybody knows the solution of this equation? This is a differential equation, but I want to focus you and explain you, first give you a simple example, a regular algebraic equation, okay? Anybody knows the solution of it? 1. It's the only solution? 0, right? 1 and 0 both solve the equation. What does it mean that it's solved? Why is it a solution? That means that if I plug it back in the equation, I will get a true statement, right? Meaning, how can I check it? I want to see if 1 squared is really equals to 1, right? X squared equals to x. Is it true? Yes, because 1 squared, I know that it equals to 1, right? But if I take something else, which is not, I don't know, let's check. For example, if 4 squared equals 4, okay? That means if it will happen, it's also a solution for the function, for the equation. But it's not, right? Because 4 squared equals 16. Okay? So 4 is not a solution for the equation, and 1 and 0 are a solution for the equation. Okay? So we're looking for a solution. We have an equation, we're looking for a solution. The difference between algebraic equation and differential equation is that in a differential equation, we don't look for a number, right? Here we're looking for a number who solves the equation. Here we will look for a function that will solve the equation. We will look for y of t, right? This is what we're asking. What is y of t? What is the amount of protein after 10 seconds, after 10 hours, after 10 days? Okay? Okay. Any questions so far? Okay. So the purpose of, in the end of this lecture, we will know how to solve and understand the solution of this equation. Okay? When I'm saying the solution is the function that solves, okay, by the way. So we will know to investigate the solution. But we first start by dividing the problem into smaller and easier problems. Okay? We will look at dy over dt equals beta, which means alpha equals 0 for that case, right? And we later look at beta equals 0 in the general case, which gives us dy over dt equals minus alpha y. Okay? So this is how we will work. Okay. So this is the simplest case in of that function. Anybody knows the solution? Anybody can guess? Okay, let's try a different way. How do we solve it? We need to know what kind of function, if we take derivative of it, it will be a constant. Anybody? Right? Beta t, right? Y equals beta t plus some function of initial conditions. Okay? How do I know it? Maybe I don't know it. How can I check if it's the right solution? Like we did here, right? We plug it back in the equation and we see if it's solved. So on the one hand, we need, if I'm claiming this is y, I need to take derivative of it, okay? D over dt of y. Okay, this is the same thing, it's just a symbol, okay, of beta t plus c. I know, okay, I need to ask if it will be equal to beta. But I know how to take derivative of it, okay? What is the derivative of a constant of c? 0, right? And beta t is beta. So this is beta. So we got beta equals beta. This is the solution for the equation. Okay? Okay. What is c? You can find it through the initial condition. And c is y of 0, y0, okay? The amount of protein in the initial condition. How does it look like? Okay, it's a linear function that starts from y0 and goes linearly with beta. What does it mean goes linearly with beta? Yes?
What are the axes?
Okay. The axis is time, right? Because we're looking for a function of time. So time and y of t. Thank you for the question. Okay. Okay. Okay, so this is the function. And it's a linear function. That means that the curve is constantly beta, right? If we take delta y over delta t, it's going to be beta. If somebody don't understand it, never mind. It's not that important. Okay? And we keep it in mind that we will go back to this solution, okay, in the end. We will see something that is similar to that solution. Okay? We'll see it later. Any question about the linear solution? Okay? So let us continue to that function. Anybody knows how to solve it? Okay. I will solve it for you, I know. This is why we're here, because most of you don't know how to solve it. Maybe before we solve it, I will ask you a question. Here we claim that the cell is bidding protein in a rate of beta. That means the differential equation is dy over dt equals beta, right? If this is the degrading term, right, which determines how fast the protein will disappear, okay, will be broken into parts, why not just write dy over dt equals minus alpha? Why do we have y here and we didn't have y here? Exactly. As much degradation there is, as much protein, as bigger y is, the more it will be degraded, right? Which makes sense. If I have 10 proteins here, and each one of them just breaks apart every 10 seconds, more parts will be broken per second than if I had just one protein, right? This is one good answer. Another good answer is, what will be the solution of this? Just like there. What was the solution? So what will be the solution here?
Line.
A line, but a decreasing line, right? And that way, after some time, we will get a negative amount of protein, right? Because this is 0. And there is no such thing as negative amount of protein. Okay? So we can look at it in two ways. So this is wrong, right? And this is what we need to solve. And this is, I think, why most of you are here. Here we solved also a differential equation, but it was not a hard differential equation. It was a linear function that is kind of easy to see and guess and understand. Here, it becomes a bit more tricky. So before I tell you this is dy over dt, right? In other words, it's also y tag, right? But this is, now I want to look at it not as a symbol, but as dy over dt, which means like delta y over delta t, right? It's the amount of protein over the amount of a small time, okay? And in that approach, I cannot go into details because there is a full course of it in mathematics, which is called differential ordinary differential equations. You just have to believe me that you can divide them and look at them as they are parameters, which means I can multiply by them or move them around. For example, I can multiply by dt in both sides of the equation. Okay? If I multiply this side, they cancel each other, and I have dy equals minus alpha y dt. Okay? And I can divide or multiply by 1 over y in both sides. Dy over y equals minus alpha dt. Is it okay to do it, by the way? Always?
It has to be positive.
Right? Not positive, it has to be different than 0. Right? This is assuming y is different than 0, and we get back to it, okay? I cannot assume something if I don't know it's true, so I will check.
Might be 0.
I know. So I know. This is why I said that I will go back to it. I cannot assume something I don't know, so I'm assuming it for now, and then I will go back and see what happens if it is 0. Okay? And actually, you can see it from here. But I will go back to it. I will go back to it, and I will maybe say a word. If y is 0, so dy over dt is 0, which means dy, dy over dt is 0, which means is constant. It doesn't change. So if in the beginning it was 0, it will stay 0 all the time, but I will write it more organized in 2 minutes, okay? Okay, so now we will do another trick, okay, a mathematical trick. This is an equation, which means this side is equal to that side, right? This is the meaning of equation. So if this side is equal to that side, also the integral will be equal, right? So I can take integral over both sides. Sorry, why? Okay? And as you can see, here you have dy, here you have dt, which means here I have to integrate by y, and here I have to integrate by t. Okay? Does somebody knows? Maybe I can write it in a way that will look more familiar to you guys. 1 over y dy equals to minus alpha. Alpha is a constant. I can take it out of the integral dt. Somebody knows what is the solution of it? Another, how do you do integral? You can ask what function, if I take derivative of it, will give me what you have inside the integral, right? Because taking a derivative and an integral is two opposite, they cancel each other, okay? So the function, the derivative is 1 over y, somebody knows? Exactly, ln y. Okay, and here I can say that I have 1, or I can just ignore it, but the integral over dt minus alpha times t. And I need to add a constant. Because whenever we add a constant, whenever we take integral, we have to add a constant. So maybe ask you another thing, why didn't I add a constant also in this side? Exactly, because it doesn't matter. If I have a constant here and here, I can move it to the other side and I just have a new constant. Okay? So we're almost there. Somebody, why do I say we're almost there? What was our purpose?
Find y.
Finding y over as a function of t. We're almost there. We have ln of y equals a function of t. Okay, so let me remind you 2 mathematical rules. I will remind you something that we need here and some other things that we will need soon, okay? So E over ln of A equals A. Ln of E in the power of A also equals A, which means whatever I have here will go there. Ln and E cancel each other, okay? It's like multiplying. It's like x times 4 and times 1 over 4, okay? They just cancel each other and equals x, okay? Same thing we do here, okay? This is what we need over there, but I will show you some other stuff. E in the power of A times E of the power of B equals E to the power of A plus B, and of course, it goes the other way. Maybe I will need something else, but I will go back if I need something else. Okay, so now after I showed you this, what should I do here? How will I find y? How can I cancel? I have a ln there, and I want to cancel him. So how can I cancel it? Okay, exactly. Take e, the logarithm, the exponential on both sides. Okay, which gives us, let me get back here. I can continue here. Okay, if we have, sorry about it. If we have, you can take e on both sides, and we have e in the power of ln y on that side, right? I just take everything and put it in the exponent, which is by that rule equals y, right? Same rule. On the other side, you have e to the power of minus alpha t plus some constant c, which is by this rule going that direction, equals to e to the power of c, e to the minus alpha t. Okay? And e to the power of c, what is it? E, right? It's a different constant, but it's still a constant, so I can just call him c. Or maybe I can say that here it was c tag, and now it will be c times e to the minus alpha t. Okay? It's just a constant. So altogether, we get y equals to c to the power of e to the minus alpha t. Okay? And this is almost a full solution. Why? Why are we missing? What do we need? Right? Exactly. We have to get rid of c. How can we do it? What do you mean? From the initial conditions. Okay? What do you mean the initial condition? If this is the function, this is the solution for every moment, so it has to be the solution also in 0, right? In time 0. So that means that y in the time 0 by the solution equals to c to the power of e to the power of 0. E to the anything in the power of 0 is 1. So we have c times 1, which is c. On the other hand, we know that it has to be equal, we demand. Right? It has to be equal to the initial amount, which is y0. So we have y0 equals c, and altogether we have y of t equals y0 e to the minus alpha t. And this is what we worked for. Okay? So now, anytime you give me, you want to know what will be the amount of protein in 2 minutes and 43 seconds. You put t, and then you get the amount of protein. Okay. So how can we check if this is the right solution? Again. Exactly, we just plug it back in the equation. And maybe in order to understand how it is, why is it a solution, let's try to see what is not a solution. Okay? For example, what would have happened? Sorry about it. What would have happened if we would make a mistake, right? You do homework, you have an exam, and you find a solution, and you want to see that you did it correctly. Okay? So maybe we did a mistake. Maybe somebody by mistake. So the solution was y equals to c times to the e mt, some other constant. I don't know, we found a constant, plus t. Maybe this is also a solution. So I cannot check if this is also a solution. I just plug it back in the equation and see if I get a true statement on both sides. If I get a true statement, if I get two sides that are equal to each other. Okay? So what do I do? Can somebody help me? I need to ask. What do I write on this side? Minus alpha, right? Times y. What is y? No, the solution. What I think that I found, right? Alpha times that. Okay? C to the e minus mt plus t. Right? On this side, what am I writing?
Derivative of this respect.
I will need to take derivative of it. Of this. Right? So how do I take derivative of it? What is the derivative of this? Okay, let me refresh your memory. E to the power of ax, tag, take derivative, maybe I will do with the t. Okay? If I want to take derivative of it by t, exponent stays the same, e to the at, but I multiply by the constant that sits next to the t. Okay, the inner derivative. Okay? So, what is the derivative of it? like you said before, minus mc times e to the minus mt, right? It stays the same, and this plus 1. Okay? Are those two sides are the same? No. I can open the, maybe we'll open, I will put it together. C to the minus mt plus alpha t, right? And it's not the same, right? You can see here you have something like that, right? They both have the same power, but the constants are not the same, right? Hmm?
You have a sign error, it should be minus alpha t in the end.
Ah, right, thank you. Here it's a minus. Okay, and 1 is not like alpha t, right? It has to be right for every t, which is not. Okay, so this is a wrong solution, like we expected. Why did we expect it? Because I didn't say it in the beginning, but when you solve a differential equation in the first order, never mind what it is, the differential equation that you will see in the course, you have only one solution, which means only one function that obeys this rule. Okay? You have a rule, the differential equation, only one function can solve it. If we know this is the solution, this will not be. Let's see if this is the solution. I will do it quickly because we are professional already, and you will be at home. Minus alpha times y, right? y0 e to the minus alpha t on the one side. Okay, so not a good solution. This is the conclusion, right? Now let's check our equation. And on this side, we have to take derivative, dy over dt, which is equals to minus alpha y0 e to the minus alpha t. And you can see those are both the same. So this is a true statement, so that means this is a good solution. Okay, any questions? Okay, so let's remember what we did. We started from the equation, okay? Yes?
Question, so you draw the solution of this equation. Is it also possible to draw the solution of this one?
Yes, I will do it in a few seconds, and then I will elaborate also a few more things that I wanted to say about it. Thank you. Okay, so we start from the equation. Remember that we can multiply and move the dt and dy if we need. Okay, so we multiply by dt. We divide by y. We said we're going to look at y equals 0 soon. And then we said if they both are equal, we can integrate over both sides. And when we integrate, it's ln. And then we have to remember the mathematical rules. And we take exponent on both sides. And very important, a lot of people come to me with this question. So what do I do now? Remember, you need to use the initial conditions to find a constant. You cannot leave it with a constant, okay? Because we don't know what the constant is. Okay. So we said we're going to take care of this little problem. What happens if y is 0? Okay, here we have to assume y is different than 0 because you cannot divide by 0. Okay, but let's see what happens if y equals 0, then dy over dt equals alpha times 0, which is 0, which is mean that y is a constant. So how do I know it's 0? Why did you say? So what do I do with it? How do I solve it? If it's a constant, and I can use what we just said, that is very important and we need to do, I can use the initial conditions. Okay? The initial conditions will say that y in the tau y at t equals 0 needs to be 0. On the other hand, it's a constant. So this constant is 0, and we know that y equals 0 all the time. This is the solution. Okay? If y is equal 0 in one moment, it will be equal 0 the entire time. Okay? Okay. More questions? Okay. So, like somebody asked me, how does it look like? I got a function. Why did I do with it? I don't know what that means, right? So let's try to understand how it looks like. A good way to understand it is by looking at two things. What happens in the time 0, and what happens after a long time to this solution. Okay? So what is y of t after a very long time? And we symbolize it by t goes to infinity. Okay? What happens to y of 0? To y? Anyone? Is it infinity because it's the power of infinity? Right, right. Why? Because a negative power is like dividing. Maybe I will write it here also in the rules. Okay, this is a few mathematical rules. Anything in the power of minus, okay, maybe write it differently. X in the power of minus a. Anything in the power of a negative power is equals to 1 over x of a. Okay? So here also we have alpha t. So this is equals to y over e to the alpha t. And if t is infinity, then alpha t is infinity. And e to the power of infinity is infinity. So we have y0 divided by infinity. And a constant over infinity is 0. Okay? So we can look at it. Okay? Is it negative any time of the function? Like, will it be negative at any point? No, right? So it starts from y0, the initial conditions, right? This is t, right? And it needs to get close to 0, right? It will never really be equal to 0, but it will get close to it. And the way it declines is by exponential decay, which looks like that. Okay? Okay, it's just decline, decreasing function. Okay. Questions? Okay, so we can ask ourselves all kind of questions about the function. One very important question that we know that we want to ask about the dynamic of the system is what?
How it changes with parameters.
Also, of course, I will talk about it. But for a specific system, I want to know, like, how does it change with parameters? It's a question that different parameters will give us different dynamics of the system, right? I'm talking about this specific solution, which means the specific for that parameters. One thing we can ask is the response time. What is the response time? Response time. The time when we have f of the amount. And I don't want to say initial amount because maybe I will write a bit bigger. I don't want to say initial amount because later we will see that it can be when we have f of the amount. Later we will see that that it can be something else, okay? It's not always initial amount. In our case, it's f of the initial amount. What does it mean? If this is y0, we can ask when will it be equals to y0 over 2. Okay, f of the amount, and we symbolize it by t1 half, which will give us some kind of intuition of how fast does this system respond. Okay? So how can we find such a t? Okay, we're looking for a t, a time that it will be equal to f of the amount. How can we find it? Right? We can put it back in the equation and ask, we can demand when will it be equal to f of the amount. Okay? Which means we demand y of t, 1/2, to be equal f of the initial amount. Okay. So what can we do? How do we solve this equation? Now it's an algebraic equation, right? We have some parameters here, some parameters here, and we're looking for t1f. That means that we want to make him stand by itself, okay? t1f equals something. So first thing we can do is subtract, divide by y0. We have 1f equals to e to the minus alpha t, 1/2. Sorry. What can we do next? We've seen something similar today. Right? What do we do with the exponent? Exactly. Before, we had ln, and we took exponent to cancel it. Now, we have an exponent, and we take ln in order to cancel it. Okay? So we can take ln on both sides of the equation, and we have ln e to the minus alpha t 1/2. Those two cancel each other, like we said. We have minus alpha t 1/2. And we can divide by alpha, by minus alpha. Okay, another rule. Ln of 1 over a, okay, equals minus ln of a. Okay? In the end, we'll have a small notebook with a few mathematical rules. Okay? So we will use this now here. I mean, this is already good, but we can write it in a more elegant way. Okay? This equals to minus ln 2 over minus alpha, and the two minus can cancel each other, so we have t 1f equals ln 2 over alpha. And this, I think you saw in the lectures, right? Okay. I think we're ready. To go and solve the full equation. But before we do it, I need somebody to ask me a question, because I know that most of you see it for the first time. So for sure there is something that is not clear. Okay, so at least one question so we can proceed. It doesn't have to be the smartest question. It can be, I don't understand, why do we do it? How does it work? What will I do if I have something else? What happens if you have a steady state? Okay, it's a good question. We're going to see a steady state in the full equation. It's going to be with more meaning. But here we always get to a steady state also. The steady state is 0. After a long time, right, you can see at the beginning it's an amount, and then it's decrease. As long as it decreases, it's not a steady state, right, because it keeps changing, until it gets to almost 0, and there we say that it's a steady state. It goes to 0, because it almost doesn't change. Okay? Okay, thank you for the question. Now I can proceed. Okay, I'm erasing it, okay? Finished, okay? Okay. and we leave it. Okay. So as we remember, our initial condition, our initial equation was that, right? And we want to solve it. So let me solve it by intuition. I will show you how you can do it. I mean, you can solve it by intuition, and you can solve it by full calculation like we did here. Okay? You can solve it very similar to it, but I will not do it. You will see it on the other tutorial, and you will also do it in your homework. I want to show you some intuition about the function. That way you will understand it better, and you will also see another way of solving those kinds of equations. So what we need to do is guessing the solution. How will we guess? We will guess by the two solutions that we already seen. Okay? What do I mean? You remember when we saw the solution for dy over dt equals beta, and we said it's an increasing function, right? So we can guess that if we start from 0 amount, okay, we'll solve it for the for the specific case of y0 equals 0, okay? So if we start from 0 amount of protein, how much will this be? 0. So we actually, in the beginning, as long as we have a little bit of protein, this is the dominant part of the equation, right? So that means it will build protein, but exponential function, but after a while, if y goes bigger and bigger, this part will be more dominant, right? So after some time, it will have to make it decrease, okay? And actually what will happen, we will get into some kind of steady state. I mean, it wants to grow linearly all the time. Maybe I will do it in a different color. It wants to grow like that. But actually what will happen that after a while, this part will be dominant until we'll get to some kind of a steady state. Okay? So this is just the graph, right? But we want a full solution. Okay? So what will be the full solution? By understanding that, and that together we will understand. What do I mean? We know that the solution of this is a decreasing function, like this, a decaying function. Okay? So we can guess that y of t will be equals to some constant times e to the alpha t. We will guess, okay? And then we can check if it's a true solution. And after a long time, we know it will be equal to constant. This is after a long time will be equal to what? To 0, like we saw here, right? So if this will be equal to 0, and both of them needs to be equal to constant, so here we have another constant. Okay? And this will be the solution for that equation. Okay? You can check it at home, check if it's obey the rule, okay, like we did before. I erased it, right? Remember, we put y tag here, y tag there, the other side of the equation, and check if it's obey the rule. Okay? And what we need is to do what? Find the two constants, exactly. So how can we find them? I want to keep it because we will use it again. And also this we will use again. So let me write here. Is it okay when I'm writing here? We will try to use some of the information that we have in order to find the two constants. First thing we can use is what? Like we did twice already today? Initial conditions, exactly. Which means in the beginning, we're assuming that it's equal to 0. We can do it to a more general case, but just for simplicity, I want it to look like this. Okay, y in the time of 0 equals to 0. On the other end, it's equals to what? To exactly C1 plus C2 in the power of 0, which is C2, and C2 e to the power of 0, which is C2. And from here we get that C1, C2 equals to minus C1. And we can use it. We can rewrite the equation by plugging it, right? We can. So now we know we're building it step by step. Y of t equals to C1 minus C1 e to the minus alpha t. Okay, we're just using it. So if it's just a constant, I can just get rid of the 1. Okay, is it confusing? Or, okay, just a constant. So it equals to c minus c to the minus alpha t. Okay, and what else can we use? Here we did one step. We need to do another step to get rid of c. Okay, we can use steady state. What does it mean, a steady state? We know that it will be a constant after a long time, right? A steady state. So if it will be constant, what can we do to the equation? Anybody? Why?
Because it doesn't change anymore.
Exactly. If dy over dt is the change of y, and we know that after a long time it doesn't change, so dy over dt will be 0 because there is no change. Okay? So steady state after a long time, okay, it's 3 different ways of saying the same thing. T goes to infinity, okay? Gives us, okay, this is one thing we had, gives us dy over dt equals 0. On the other end, we know it's always equals to beta minus alpha y steady state, y of t equals infinity, right? So we know we can move it to the side and divide by alpha. Let me do it. Alpha y steady state equals beta, y steady state equals beta over alpha. So we know after a long time, this will be the amount of protein. And we can go back here and demand it. Okay? Y of t goes to infinity. Okay, this is how I symbolize it. On the one hand, equals to beta over alpha. On the other hand, we know it's obey the rule of c minus c to e to the minus alpha t infinity. But what happens to this term, like we did there? It equals 0, right? Which means c minus 0 equals c. And we get that c is equals to beta over alpha. Okay? From here, we get c equals beta over alpha. Okay? So now we have the full solution. We have y of t equals beta over alpha minus beta over alpha e to the minus alpha t. And this is the full solution for the full equation. Okay, we can write it a different way, just taking the beta over alpha outside the brackets. Okay? Okay. I will write it here bigger. Final solution. Okay? Now, here I think it was a bit hard to understand how I know how to draw it, right? I was telling you guys, look at small alpha. We don't expect you to do it for the first time and understand it, because it's I did it with some mathematical background. But so let's see. a different way, how can we build this graph from by looking at the solution. Okay. So in order to do it, I need some space. Yeah, we can do it here. So let's look at our solution. Let's build it. It has y of t equals to beta over alpha minus beta over alpha e to the minus alpha t. So beta over alpha e to the minus alpha t. This is t. How does it look like? Like we saw here, okay, like y0, just a decline function, right? But here we have a minus. What happens to a function when you take a minus? Right? It's like a mirror over the x or the t-axis, right? So every point here goes to the negative picture over, right? So it looks like that, okay? And this is minus beta over alpha e to the minus alpha t, okay? But now this is what? Minus beta over alpha. And the full solution is adding beta over alpha. What happens when you're adding a constant to a function? It just everything jumps, right? Adding a constant plus a constant, like every point going to the same value plus the constant. So what happens is that. Okay. And this is beta over alpha. It goes exactly by beta over alpha because this is what we added. And it was minus beta alpha in the beginning plus beta alpha, it's 0. Okay, so this is why it jumps over here. Okay. Any questions? Okay, so let me go back to what you asked me before. You, what's your name? Ja. Okay, nice to meet you. Ja before asked me, what happens to this? Maybe we can look at different alphas, different betas, right? So let me talk about it a little bit. What happens if we have a bigger alpha, for example? Let me go back to this graph. What will happen to the entire graph, and specifically, what will happen to the response time? Suggestions? Okay, I will give you a hint. Remember, this is y0 e to the minus alpha t, which is equals to y0 over e to the alpha t, right? So if alpha is bigger, for example, what will happen to that? Alpha t will be bigger for every moment, right? So e to the alpha t will be bigger. So the entire function will be also bigger? Smaller, right? Because we divide by it. If we divide by something big, we get something small. Okay? So for every moment, this function will be lower. Okay? So the response time will be smaller, which means it will respond faster, right? Because it just moved to the side. Okay? For example. Okay. Now, what happens? Okay? And the bigger we make alpha, the more it will move here. If we make alpha smaller, it will look something like that. Alpha is smaller. Alpha is bigger. Okay? Okay, so this is one thing I wanted to say. Now, what other parameter can we change? Can we change t? No, it doesn't mean anything, right? T anyway changes all the time. It's a function of t. Can we change beta? Yes. What will happen if we change beta? Okay, what is the meaning of beta? How fast do we build, right? So, okay, so if we change beta, we will build faster. And what also will happen? Y steady state goes like beta, right? So Y steady state will be higher. Okay, so here, if we change beta, we will get something like that. Okay, if we increase beta, we make it bigger. It will build faster, right? Because every moment we can see it's higher. And also the steady state will be higher. Because Y steady state equals to beta over alpha. Right? This is Y steady state. Okay, this is the other Y steady state for bigger beta. Y steady state bigger beta. Okay? So, before I say something else about it, no, maybe I will say it now, and then we'll show one more thing, and then we'll finish. Can anybody think of a case that Y steady, we will change beta and alpha, but Y steady state will not change, will remain the same? Same ratio. Exactly, which means we'll keep the ratio between them. And instead of making alpha, if Y steady state equals to beta over alpha, it also equals, for example, 3 beta times 3 alpha, right? Because we can divide the two 3, and it will remain the same. Okay? So your purpose is to find Y steady state, the response time for this system, okay? For the full solution, for the full equation. Sorry for that. Okay? You remember here before we found the response time by for the simpler case when it was only alpha, dy over dt equals alpha, and this was the solution. Now take 2 minutes, okay, 1 minute. We don't have a lot of time. Take 1 minute and try to find the response time. Okay. Okay, well. Let me clear up some space. I will do it also. I'm just giving you some time so you can practice it. Right? I know it's weird. Okay, so I see some people are finished and we have to finish also. So, whoever got a solution, what did you got? Did you got anything? Did you finish? What did you got? Hmm? Sorry?
The new response time.
Yeah.
Just multiply by this constant. For instance, ln of 2 divided by 3 alpha.
No, wait. I'm asking the general case. Okay, you did something good, but it's not what I asked. I'm asking, this is the solution, right? For every alpha and beta. I want to find the response time from that. Okay?
You get what's there.
Right? And does it look weird, right? Okay? I mean, well, how is it possible that we're getting the same response time? I mean, before we didn't build anything. Now I'm building. I can build as much as I want or whatever and still have the same response time? Something is fishy here. Maybe we have a mistake. Maybe this is not a solution. Anybody have some intuition about it? Okay, it's the true, right? We get the same. I will get it soon. Okay, I will show you the calculation. But before we do it, I want somebody to help me understand how is it possible that we're getting the same solution? How is it possible that now I'm building faster, I'm increasing beta, and I'm still getting the same response time? Anybody? Okay, I will tell you. Okay, because we have two effects, right?
Degradation also.
What?
The degradation is changing also.
Yeah, we can do it, but I'm talking about looking at the general solution. Maybe I shouldn't. I'm not looking at this. I will go back to it soon. And now I'm saying, before we didn't talk about making alpha bigger or smaller. I just said that before we were just looking for response time for the general function, and we saw it's dependent on alpha, right? Now I'm saying, again, let's find the response time. So maybe I will solve it first, and then we talk about the intuition of it. Also, it will give you time to think about how is it possible. Okay, so let me find the response time. Now, before, remember I told you it's the f of the amount. Before it was the f of the initial amount. It started from y0, and when we get to y0. Now, it starts from 0. And I want to ask, it starts from 0, and I want to ask, well, we'll get to the f of the final amount, okay? Y steady state over 2. So again, like we did there, I will do it a bit quicker because we did something very similar. We will ask beta over alpha. This is y steady state divided by 1/2, right? Equals to beta over alpha 1 minus e to the minus alpha t. Okay? We can divide it. And now we can move this to that side and that to that side. E to the minus alpha t equals to 1/2. And we have exactly what we had here. Okay, so we can jump those stages and get to t1f equals to ln alpha over 2. Sorry, ln 2 over alpha. Okay? Same as for beta equals 0, which is not too surprising when you think about it, because anyway it was not depending on beta, right? So again, let me give you some intuition. Here we said that how is it my question, what's bothering me, is how is it possible it doesn't depend on beta? If the response time, the meaning of it is how much time will it take me to build f of the amount, and I know that I'm increasing the rate that I'm building, how is it possible that it doesn't change it?
The amount is different.
Exactly, because the amount that you're building is different. So you build faster. Why the amount is different? Because y steady state is different, right? We said it's depending on beta. Y steady state was beta over alpha. So I'm building more and building faster. Again, I'm building faster, but I'm trying to build more, okay? So those two cancel each other, and the response time would be ln 2 over alpha, okay? Yes, and we can look at it as like, what will be faster? Driving from here to Tel Aviv in 100 kilometers per hour, or driving from here to Haifa in 200 kilometers per hour, okay? You drive faster, but also longer. Okay, I think we can wrap up. Let me see if I forgot anything. No, we're good. Somebody have any last questions before we close? Before we wrap everything up? Okay, so thank you very much and good luck. If somebody has any more questions, you can come and ask me. Okay.